Dear students, I am myself Professor Ashok Chaubey, working as a Assistant Professor in Electrical Engineering Department. Now we know that in the last two lectures we have seen the high voltage engineering. It means that when we are studying the high voltage engineering, we are seeing that the main thing is going to be the breakdown. It means why the breakdown occurs and what is the reason behind the breakdowns in gases, liquid, as well as the solids. Solid may have also the composite solids. So in this last lecture, we have seen the breakdown in the gases, what is the ionization, what are the types of the ionization. Now today we will see secondary ionization process. So there are two types of the ionization process, primary ionization and secondary ionization. Up till now, what we have seen, that is the primary ionization. Now, what is the difference between the primary ionization and secondary ionization? You know that when you suppose that there are two electrodes, anode and cathode. So what happens when the supply electrical field E is applied? Then what happens? Electrons are emitted from the cathode and they are reaching to the anode. They are reaching to the anode because anode has the positive electrode and cathode has the negative electrode. When these electrons are emitted, so secondary ionization means what happened actually? The number of electrons that are reaching to the anode must be equal to the number of electrons that are emitting from the cathode. But in fact, this does not affect. This does not affect. This does not in practice. So what happened? What is the secondary electron? The number of electrons reaching the anode per unit time is greater than those liberated at the cathode. This is due to rise of the secondary electrons. And the ionization that takes place due to this secondary electron is called as the secondary ionization. So we will see in detail what is the secondary ionization. So secondary ionization firstly happens due to emission of electron emission due to positive ion impact. It means that both cases are happening. If negative ions are going to be impact, again there is a release of the electrons, and when the positive ions are going to be impact, there is the emission of the electron. So this is that ionization by collision or photoionization causes formation of positive ions. The formation of this positive ion, when between they are going to be attracted, they are going to be attracted to the cathode. This travels over the cathode. When a positive ion approaches a metallic cathode, it causes the image of electron from the cathode. It means what happened? Actually, what happened? Total ionization, there is a emission of the electrons. The emission of the electrons due to the positive ion impact on the cathode, that is called as the electron emission due to positive ion impact. In this process, the positive ion give away its kinetic energy. If this ionization is greater than twice the work function of the metal, what happened? If this ionization energy is greater than twice the work function of the metal, then one electron will be emitted. And this secondary electron will neutralize the ion. This is going to be the first one, that is the electron emission due to positive ion impact. Now second one, electron emission due to photons. What is this photons come from? These photons come from ultraviolet light energy. Ultraviolet light energy of a suitable frequency. It means that if some energy is given in the form of it may be the photon, then what will happen? The electrons are emitted. Electrons are ejected from the cathode. And this is called as the electron emission due to photons. That means some energy is required when we are going to apply the voltage. There is going to be the electrical energy is going to be applied. In this case, what happened? Energy in the form of the photon is going to be put up. See here, if the electrons is to be dislodged from the outer shell, it should be given enough energy. Just I have told you that some energy is required. If it is going to be dislodged, or it is going to be ejected, or it is going to be emit the electrons from the cathode, it overcomes the surface potential barrier. It means the surface potential barriers of the cathode is going to be overcome by this energy. The external energy can be supplied in the form of the photon of the ultraviolet light of a suitable frequency. Right? This is going to be the two methods we have seen. Firstly, what we have seen, electron emission due to positive ion impact. It means how the electrons are emitted due to the impact of the positive ion. Now, second one, electron emission due to photons. It means that the photons from the ultraviolet energy is going to be bombarded. Then what happens on the cathode? They get a sufficient energy to overcome the surface potential barrier. Once the potential barrier is going to be overcome, the electrons are emitted. Now, third one is going to be the electron emission due to metastable and neutral atoms. Now, the question arises, what is the metastable atoms and what is the normal atoms? Metastable atoms are nothing but the excited particles. What is this? Metastable atoms are nothing but the excited particles. What is the difference? The difference is that the lifetime of the metastable atom is very high as compared to the normal atom. Do you know the point? That the lifetime of the metastable atom is very high as compared to the normal atom. So when the metastable atom is an excited particle, the lifetime of a such metastable atom is very large as compared to lifetime of ordinary particles. And electrons can be made to eject from the metal surface by means of impact of the metastable atom. If the metastable atoms are going to be impacted, then the electrons are good. So what is the effect? They have the more lifetime. So more lifetime, it means they can save, they can survive for the more time. If they survive more time, that will happen, they will reach to cathode at sufficient time. Once they reach the cathode, the electrons are emitted from the electron. So these are what we are going to study. These are the secondary ionization. Now the next one is electron attachment process. What is this electron attachment process? We know that some gases are electronegative in nature. What do you mean by electronegative nature? It means the electronegative nature, it means that they have the deficiency of certain electrons. Up till now, what we have seen, there is a dislodge. It means there is a disattachment. Here is the attachment. It means what happened? Up till now, the electrons are ejected. But now in this case, what happened? The electrons are absorbed. Why absorbed? Because this nature of the gases is electronegative gases. It means they have the affinity for the electron. So here see, they have affinity for the electrons. Attachment is a process in which electrons may become attached to the atom to form a negative ion. Negative ions, it means if the number of the electrons are more, surely they will be negative. If the number of the electrons are less, it means they are the positive ions. Electrons attachment process depend upon the energy of the electron and the nature of the gas. Whatever the depending electron attachment process depends on the energy of the electron and the nature of the gas. The outermost orbit of the attaching gases or insulating gases have vacancies. Just I have told them why they have the affinity. They have the affinity because they have the deficiency of the electrons in the outermost orbit. And these are supposed to process affinity for electrons. the free electrons present in the ionized gas are absorbed due to vacancies. And the main application of this electron attachment process is nothing but in the circuit breaker. When the arc quenching is going to be needed, that at this time, this electronegative atom, the electronegative gases are insulating medium are put up in this bench. They have the attachment or they have the affinity for the electrons. As they have the affinity for electrons, they will attach all the free electrons for that one in the arc. And so there is a easily arc is quenched from that. Now, we will see what are the various factors influencing the breakdown in the gases. It means what are the different factors that are influencing. Up till now, what we have seen, we are seeing the breakdown in the gases. We have the breakdown in the liquid also. We have the breakdown in solid also. So, what are the different factors that are going to be affecting the breakdown in the gases? First one is the distance between the electrons. The distance between the electrons. If distance is more, breakdown voltage is higher. Because if the distance is more, it means the electrons or that one particles have to more distance. As they have to travel more distance, sometimes we also in the case of metastable atom that they have the more energy as compared to ordinary. But what happens for the ordinary atom? The ordinary atom have the less lifetime, so they collapse. It means that the first one is the distance between the electrons. Now, second one, shape of the electron. Whether it is spherical, whether it is going to be plate type, or whether it is going to be the normal type. So this is going to be and the size of the electron. Third one is going to be the size of the electron. And the fourth one is the material of the electron. That is going to be important. Which type of material they use for the electron, whether it is copper, which is other aluminum. What are the electrode type? That is also going to be affecting the breakdown in the gases. And the next one is the material between the electrodes. It means what is the material that what is insulating, what is conducting. This type material between the electrodes. Now, sixth one is the temperature. Seventh one is the pressure. And the eighth one is the applied voltage. Applied voltage is more electrons are ejected, more electrons are reaching to the anode. So thank you, students. We have seen. Now in the next lecture, we will see what is the avalanche and what is the Townsend's theory, or we can also see what is this Paschen's law. We can also see the Paschen's law. Paschen's law is important because it gives the relationship between the pressure and the distance between the electrons. That is going to be important. The Paschen's law will give you the relationship between the pressure and the distance between the electrons. It means what is the relationship between the pressure and the distance of the electron, and what is the formula for find out that voltage